Students online, all of you all, very good morning, everyone. Very good morning. Welcome to today's class, all of you all. I hope all of you all are keeping fine, doing good. So all of you all, we continue with our theory work. Okay. We were in chapter number 3. We were talking about primary memory and secondary memory. We are going to move forward from there onwards. Okay. Right. Hurry up, boys. Come on in. Come on in. Come on in. Come on in. Guys, girls, can we all move on to chapter 3? We'll continue from where we stopped. Okay. Now, guys, girls, boys behind. Can you move to the next chair, please? Aman, next chair, please. Yeah. Hurry up. Now, guys, girls, when we speak about computer memory, we broke it down into two main categories now. What were those two main categories? You had your primary memory and you had your secondary memory. Give me a second, please. Okay. Under primary memory, Aman, did you understand what I told you? Move that side. Okay, under primary memory, what did we have? We had RAM and ROM, right? RAM stood for random access memory and ROM stood for read-only memory. Okay? Hurry up. Okay, then guys, when we spoke about the RAM, I gave you all the RAM has two functions only. I told you all the RAM has two functions. Function number 1 was to hold information, or we could say data, okay, for a short period of time. So what type of data or what type of information is it holding? Volatile, no. Specific, no. Running, programs running, right? Programs that are currently running on your computer. Programs currently open in the background, running in the background. Your RAM is holding them. Isn't it, guys? If I press Control Shift Escape right now, guys, girls, look here. If I press Control Shift Escape, look at my screen. Right now, it's telling me my RAM is 93% full. 93% full of what? It's saying your server is running, Microsoft Word is running, Notepad is running, Task Manager is running. Can you see? It's saying your server is taking about 20 MB of space. Okay? Yeah. It's saying your server is taking about 20 MB of space. Microsoft Word is taking, you guys can see this, right? Everyone look at this. Let me zoom in once more. Can everyone look over here? Can everyone look over here? You can see, for example, Zoom is taking up the most amount of space. Zoom is taking up the most amount of space. So the RAM, girls, all of you all, the RAM is responsible for holding programs that are currently opened. Function number 2 was when you open up a program, let's say you open up a movie. Okay, let's say you open up, what does it do? I didn't get you. No. It takes the files from
the hard disk.
Hard disk, secondary storage. Yes. It takes data from secondary storage and gives it to the CPU for what? For processing? Exactly. You would send it to the processor for processing. Everybody okay with this? So these are the two functions of your RAM. There is something known as virtual memory. When does virtual memory take place? We learned of something called exactly when the RAM is full, virtual memory is created. Who creates virtual memory? Very good. Operating system. Your operating system creates virtual memory. When virtual memory is created, does your computer speed up or slow down? Significantly slows down, because now who is also acting as RAM?
Secondary.
Exactly. Secondary storage is also acting as RAM. Isn't it? So your computer gets significantly slow. So if I were to ask you, how do you avoid virtual memory? How do you avoid getting to the stage of virtual memory? One second. Upgrading your RAM, that's one answer. Exactly. Closing apps that are no longer being used. So when we do our practicals also, I tell you all, now close everything. Okay, free up your RAM. Otherwise, if you keep files open in the background, what happens? Slowly your computer is going to start getting slow. Okay, that's what I tell you all. Keep closing programs as you all go along. What you all don't need, close it. Free up your RAM. Are we okay with this? Right. That is it. That is it with RAM. What does ROM do? ROM has only one function. Store BIOS. BIOS stands for Basic Input Output System. And what does it do? It tells your computer how to. That's it. Perfect. BIOS tells your computer how to start up. Everybody okay with this? Then guys, when we came on to secondary memory, we covered something known as optical disk. Everyone with me, boys? When we came on to secondary storage, we spoke about optical disks. Under optical disks, we had three types. What were the three types? CD, DVD, Blu-ray. From these three, which one had the highest capacity? Blu-ray. Okay. Then guys, in a CD, DVD, Blu-ray, in any optical disc, if you were to use a magnifying glass, you would see, exactly, you would see pits and flat areas, isn't it? A pit represents a binary value of 0 and a flat area represents a binary value of 1. Everybody, this is where we came and stopped at last week. Okay, so let me quickly show this to you all. I know, you don't need to tell me that. Okay, let's move down over here. Can everyone come down to optical discs? Okay, right. One more thing I want to tell you guys. When you guys come down over here, where is it? This particular part, I don't remember whether I told it to you all or not. Right, can you guys look at this? Guys, girls, can you all read this on page number? I zoomed in a bit too much. On page number, what's the number? 58. On page 58, guys, can you all read that last sentence? Optical discs can either be read-only. If they are read-only, it will say CD-R, DVD-R. Is it clear? Blu-ray R. Everybody okay with this? Can you guys see this? Okay. Are we all okay with this? Okay, optical disc can either be read-only or they can be rewritable. Are we okay with this? So guys, what do you mean by read-only? In a read-only disc, you can only read data in it. Meaning, in an optical disc that is R, okay, read-only, you can only change data once. Everybody okay with this? In an optical disc that says R, you can only change the data once. Thereafter, users cannot change the data. However, in a CD-RW, in a DVD-RW, you can modify the data as many times as you want. What does RW stand for? Rewritable. You can keep changing it as many times as you want. Are we okay with this? Everybody? So guys, now think about this. What are instances where you would use CDR? When watching a movie. So the software producer of a game would give you the game installation in a DVD-R. Because is there any need for you to modify the game? No. Absolutely no need for you to modify the game, right? So they would give it to you in DVD-R. Okay, but say for example, you're exchanging files with your friends. You would most probably use DVD-RW because you might change the files later on. Are we okay with this? So software setups and all that normally come in a CDR, DVD-R because there's no need for you to modify the software. We only want you to install the software. You guys get my point? Okay. But in today's world, do we even use CDs? No. In today's world, we don't even use it. Okay. Everybody okay with this? Sounds good? Right. Then guys, we went through all these. Okay. So now where we need to continue from is your hard disk. Okay. So everybody, guys, all can come in. Okay, so everybody, in the hard disk, guys, we spoke about the part of the hard disk. We'll have to move behind. The data on a hard disk is stored on your platters. The data on a hard disk is stored in your platters. Is it clear? So the more platters you have, the more data that you can save. Am I right? Then guys, to take data from these platters and to put data to these platters, what do we have? We have an arm, right? Read-write arm. Everyone, can you all see this? Guys, on my textbook, on the textbook, it just says head arm. Can you all change that to read-write arm? Either it's reading data, it's either taking data, which is read, or it's putting data, which is write. Can you guys check that out? So don't cut it. On top, just say read-write arm. Don't cut this. Just on top, say read-write arm over here. Read/write. It reads data. It also adds data. Read/write arm. What's wrong, boys? Read/write arm. Everybody okay with this? Read write arm. Okay. Right, guys. Now, everybody, last week I did not show a video on how the hard disk works, right? I didn't, right? Okay. Then give me a few seconds, please, to find it. Okay. Guys online, let me find the video first and then we will move forward. Girls, can I have your attention here, please, everybody? I'll be skipping many parts. Also, the volume here is good. About flash memory. Previously, I gave you all a really long word for flash memory here. Anyone remembers it? EEPROM. Yeah. What does it stand for? Electrically erasable, programmable, read-only memory here. Nothing remember this? Remember? You didn't come exactly here. Electrically erasable, programmable, read-only memory here. Everybody okay with this? Normally, this is the name for flash memory. Do you all remember the advantages I gave you all for it? I gave you all many advantages for it. Anyone remembers? In your writing book or in your textbook, you'll took it down. What were the advantages? Low power consumption. Excellent. EEPROM flash memory has extremely low power consumption. Next. It has no moving parts. So what's the big deal? 1 second. No moving parts. So less prone to physical damages. Excellent. Something else? What do you call? Very high read-write speed. Something else? Not high storage. It's very slim. Okay. Extremely slim. Right. Now, guys, can you all read these benefits again? Everybody read these benefits again on page number 60. Guys, girls, can you all see the same benefits I have mentioned again? Boys, girls, read this fellow. All of y'all boys, can you all read these benefits again? High read-write speed. Okay, very slim in size, light in weight, consumes very little electricity. So excellent for rechargeable devices. Are we okay with this? Keep reading it. It has no moving parts, so less prone to physical damages. Are we okay with this? Okay. Then, guys, girls, can you all see the devices which come under the category of flash memory? Everybody, can you all see the devices which come under flash memory? What are they? Memory cards, pen drives, SSDs. Can you all see what SSD stands for? Solid State Drive. Are we okay with this? Everybody, shall I give you all 30 seconds to go through these again? Okay. Girls, all of you all there? Okay, have a look at the benefits. Have 2-3 benefits in mind, boys. Have 2-3 benefits in mind and have examples of flash memory. What are they? Okay. Page number 60, have you turned there? Okay, right. Okay. Come on, guys. Have 3 advantages of flash memory below. Why did flash memory become so popular? Here are the reasons. Okay, very slim, light in weight, high read-write speed, low power consumption. Okay, because in today's world, we are all using rechargeable devices, right? We want the battery to last for as long as possible, isn't it? So then flash memory is your go-to option. Okay. Flash memory is very nice. Storage media. And then memory card, pen drive, SSD will be your perfect storage device. Excellent. So shall we have a look at SD cards, guys? Boys, all of y'all? With your fingers, do you all agree that this is the size of an SD card? Literally this size, right? So easy to lose it. Okay, it's like a SIM card, isn't it? But its storage capacity is significant, right? Okay, it has a huge storage capacity here. Okay, right. So guys, for your practicals and all that, I give you all a pen drive, right? Inside that pen drive, I have a memory card. Everyone, do you all know about it? So I normally give you all. Guys, girls, normally, I won't be giving this to you all again. I told you all right. Now today I'll be giving all the practical files for you all to download, boys. Tomorrow I will not be giving you all pen drive to copy and paste files. Download it and come. If you all don't download it and come, you all have to somehow find the files. Okay, I'm not going to be giving this pen drive. Everyone, look here. When I give you all this pen drive, inside this pen drive is a memory card. So then what do you think is this? This is the memory card. Can you guys even see from there? Okay, it's really, really small. Then what is this? This is not SSD. Adapter, very nice. This is my memory card reader. So I put this into this, okay? And then since many of your laptops don't support memory card reader, I plug this into my pen drive. Everybody okay with this? Just what do you call it? Not part of your syllabus. Why do you think I'm using a memory card? No, why don't I simply use a pen drive itself? No. Okay, how can a memory card not spread viruses? So guys, if you all look, you all can't see it from there. On the side of the memory card reader, I have a lock button. When I push this down, the memory card gets locked. So when you all plug this into your laptops, if your laptop has a virus, it cannot enter the memory card because the memory card has been locked. Lock means what? It's read only. Read only means what? You can only take data. Can you add data? You can't add. Can you modify? You can't modify. Everybody okay with this? With a pen drive, I don't get that feature. With a pen drive, if I give you guys a pen drive, you all can change the data on the pen drive. Okay, so for example, if there's a malware on your laptop, it's going to enter the pen drive. Then the next person takes a pen drive, plugs it in their laptop, the malware is going to go onto their laptop. And like this, the malware is going to spread to all our laptops. That's why I don't use pen drive. I use a memory card because memory card, once I copy the files, I lock it. So then when you plug it into your laptop, you can only read. You can't write anything to the pen drive. You can't make any changes to it. Are we good? Okay, right. Guys, girls, can we move down to the next page? Pen drives. You can also, pen drives can also be used in today's world. Extremely small, very light. Guys, if you were to open up this pen drive, you would see a single chip, board. There won't be multiple moving parts. Everybody okay with this? Then guys, we have solid state drive. Look here. This is why the MacBook is so slim, because it's using a solid state drive. Boys behind, okay there? Okay. They don't use hard disks, okay? Because hard disks are extremely bulky, okay? Guys, can you all read SSDs? Everybody, have a look at SSDs below. Have a look at SSDs below. Okay. So I never gave you all a disadvantage, but here there's a disadvantage, which is high cost. High cost. So generally, SSDs have a lower storage capacity. Why? To make it more not safe. You just told me they're expensive now. So generally, SSDs have a lower storage capacity to make it more affordable, cheaper, not cheaper, affordable. Was that okay there? Generally, SSDs have a lower storage capacity to make it affordable. Okay. Hard disk, normally you can easily get you can get a hard disk for 1 terabyte. Okay, but SSD is normally 128, 256, 512 GB. Is it clear? They bring down the capacity to make it affordable. Are we good? Everyone? Sounds good here? So now, guys, things are going to get a little, not little harder, a lot harder from this point onwards. Okay, I'll have your writing books now, no, everyone? Everyone has a writing book here? Okay, calculations are about to start now. I didn't get you. What do you tell?
No, SSD, the high cost compared to
HDDs, yeah. Hard disk drives, yeah.
Hard disk drive.
We did hear, no, hard disk drive?
The hard disk. Hard disk drive is the hard disk.
It's the hard disk, yeah, yeah. So you can say hard disk drive or you can say hard disk, okay? Right, everybody, can we come down here? Something new for you guys. Everybody, can you guys come down over here? Boys, girls, take your pens out below. Everybody, guys online, can you look over here? K makes copies of her work files. Everyone with me? What's wrong? Everything okay there? Okay? Don't just say Atif. Who doesn't have the textbook? You or him? You. Then at least note down the question number or the page number and note it down. Page number 61. One reason magnetic tape. Stop there for a second. Did we ever learn magnetic tape? We didn't learn magnetic tape, right? Yes or no? We didn't learn. I taught you all magnetic disc. I never taught you all magnetic tape. Everyone have a look at this. Have a look at this image over here. Who doesn't have a writing book? You also don't have. You also, who do you tear a page? You didn't bring. Okay. You also didn't bring it. Everyone, we need to have a writing book. Take down your notes for today. You also don't have a writing book. Don't have a, didn't bring. Okay. We all must be having a writing book for ICT guys online. You all too, because notes will keep coming up. Now we're going to do some calculations. Right. Everyone have a look at this. Magnetic tapes. Okay. Have you guys ever seen anyone storing data on this? Chances highly no. Okay. Can you see over here? I'll take this. Anyone knows what we call this even in the first place? Cassette. Very nice. We call this a cassette. So guys, inside a cassette, you have tape inside it. Your data is stored on that tape. Is it clear? Everybody okay with this? Have you guys ever seen? Why is the image not opening up? It can be very high because the cost is very low. But we have a major problem with magnetic tapes.
They get damaged when exposed to magnetic.
Okay, that's one. A bigger problem than that is?
Yeah.
Not expensive. They're cheap. I just told you, right? The capacity is low. I mean, their capacity is high because they're so cheap. Okay, I mean, I'll get back to you.
They get damaged.
No. A problem with now, guys, when you watch a movie on a pen drive, let's say the movie is 2 hours, can you directly jump to the 30th minute?
Yes.
In a pen drive.
Yes.
In a pen drive, you can directly jump to the 30th minute, right? In a cassette, you can't do that. You need to fast forward until you get to the 30th minute. Then you can. Is it clear, guys? So previously, users who use cassettes, okay, let's say, for example, there is music in it, or there is a what do you call audio clip in it, and they want to get to the 30th minute. You know what they would do? You don't cut it, then you're losing your data now. So, for example, they would put a pencil in that hole and keep turning the tape until they get to that point. Everybody okay with this? Either you can fast forward, you can keep fast forwarding until you get to the 30th minute. Or, for example, over here, they use a pencil over here or a pen or whatever and keep rotating this until you feel like the tape has got to the 30th minute. Everybody okay with this? You can't randomly access data in a magnetic tape. Everybody okay with it? Magnetic tapes use something called sequential access. Shall I tell that word again? Magnetic tapes use something called sequential access. Sequential access means what? You can't jump to a specific point. You have to start from 0 and keep moving forward. Everybody okay with this? Now in pen drives, can you jump to a random point? Answer is yes. In a pen drive, you can. In a pen drive, you can jump to the 50th minute, not a problem. But in magnetic tapes, you can't do that because they use what type of access? Sequential access. Magnetic tapes use sequential access. So you have to start from the 0 second and then keep moving until you get to the 50th minute. Are we okay with this? So do you think people are patient enough to use this in today's world? No way. We are not that patient. We want things immediately. Everybody okay with this? Right. Now, guys, can you come and answer this with me? One reason magnetic tape is used for this is because it can store more data than storage media. Explain one other reason magnetic tape is a good choice. It's extremely affordable. It's cheap. Okay. So explain, if you say cheap, you have to go on to explain it. Okay. So you can say the cost per GB. Okay. The cost per GB. Now, GB I haven't taught you all yet. It's a memory unit. Okay, like we have kilometers per hour, like we have kilograms, grams. GB is a unit to measure how much of data. We're going to be learning it today. Okay, the cost per GB is very low in magnetic tapes, thus making them very affordable. Okay. Boys, girls, good with this? Come on in soon. I think we need to change our class now. Hurry up. One can come here. Yusuf, where are you going to sit? You can sit there. No, come here. Come here. Atif, give him space. Okay. The cost per GB is very low in magnetic tapes. thus making them very affordable. Right, guys, girls, give two types of peripheral storage media. Underline media, please, because that's very important. That a tablet computer could use. Flash memory, that's the easiest answer. Right, something else? SSD storage device, not storage media. Optical for a tablet. But I think the marking scheme accepts it. But what is the next closest choice? In today's world, all tablets are using flash memory. But you need to write one more answer. What's the next closest answer you can put? Hard disk. Hard disk is a storage device. What's a storage media? Magnetic disk. Magnetic disk. Okay, everyone? Flash optical disk marking scheme is accepting, but practically speaking, you can't use it, right? Okay, so we talk about flash memory and magnetic disk. Can we move down, boys? All good there? Right. Over here it says, Howard sells his old hard disk drive to Steve. Complete the table by ranking the storage devices in order of their read-write speed. So which one do you think here is the fastest? SSD. What does it stand for? So C. Then there is no D even. B. Okay. A and then B. No, B is the slowest. Isn't it? Optical disk drives are the slowest. Isn't it? Okay. Yusuf, what are you waiting for? Okay. So the fastest is solid state drive. Okay. Right. Describe two factors. Describe two factors that affect the read-write speed of a hard disk drive.
The speed of the platter.
Speed of the platter, we never learned something like that. RPM of the spindle. Okay. You were going to say that? What were you going to say? Dust. Yeah, read the question. Speed. So Aman, if they said what are the factors that contribute towards damaging a hard disk, then I would take your answer. They said speed. Everyone, can we get down his answer? He said what? The speed of the spindle. Now go on to describe it. A higher RPM, put in brackets the meaning of it, revolution per minute. A higher RPM would lead to more rotations every minute, thus allowing for more data to be accessed every minute. Agree with me on this now? A higher RPM belongs to your spindle. The faster the spindle rotates, the more data can be read or written. Yeah, what about the second answer? I didn't tell it to you all actually.
Like something about read-write.
Very nice. So everyone, I never told it to you all. Your read-write arm is there now. Your read-write arm speed in reading data or writing data. Everybody okay with this? So your second answer will be the delay in the read-write, in the read/write arm in accessing data from the platter. The delay in the read-write arm in accessing data from the platter. While you all are writing this, I'll ask you one more question. These are all hardware answers now. Your hard disk is slow. Using what software can you speed up your hard disk? Very nice. Defragmentation. Using defragmentation, you can speed up. Basically, what does defragmentation do? Can you say fragments? Organizes the fragments of data on your hard disk drive. So you can access them quickly here. Okay, everybody okay with this? What's wrong? Okay. Right, guys, I'm going to keep moving down. All right. Okay. Okay. Right, guys, let's move down here. There is another question. Which one of these uses magnetic media? Answer is hard disk, magnetic, no? Okay. Why do we say magnetic for hard disk? It's all magnets that are keeping those components all together. Is it clear? A lot of magnets are used to keep the components inside a hard disk together. Are we okay with this? That's why we say magnetic media. Okay. Which one of these is type of storage media? Storage media. I don't know. You all read and tell me. 1 minute. Storage media means what? Technology used to store data, right? Technology used to store data. 1 second. Now, which answers are out? SSD is out. SSD is a storage device. Solid state device. Okay, so SSD is out. RAM? RAM is a storage device, right? It stores programs running in the background. So RAM is also out. Magnetic tape? Which one? Magnetic tape. Okay, hold on. Then CD drive? CD drive is a device, right? CD drive is your device. It is used to store data. The 1 second. The storage media of a CD drive is optical disc or optical media. Okay, so over here you guys are going to be marking which one? B, magnetic tapes. So we have magnetic tape, which we are no longer using in today's world. And we have magnetic tapes were there. We are no longer using this, but we are still using magnetic discs. Okay. Magnetic discs are being used in today's world. Right. Awesome. Okay. What about this one, guys? Okay. Very nice. Very nice. The first one is platter. Okay. Boys, platter. Then you have your spindle. You have your spindle over here. And then finally, what do you have? Your read-write arm. Okay, excellent, boys, girls. You can. Or you can even put as what textbook, what do they say? Actuator. Okay. Everyone writing with me? Okay. The game is stored on a DVD-R. Everyone know what that R is for, right? Read only, right? Explain why the game does not require rewritable. Exactly. The developer wouldn't want his game to be modified, right? There is no need for you to modify the game. One more question, guys. Where do you install the game? On your local storage, right? You would install the game on your local storage, which might be a hard disk, which might be an SSD. Everybody okay with this? So guys, girls, let's note that down over here. Let's say over here, it does not require RW storage media because, everybody, let's mention over here, it does not require RW storage media because there is no need for the user to modify the game setup. Okay, there's no need for the user to modify the game setup, and further, the user would be installing the game on their local storage. On their local storage means on the user's hard disk or the user's SSD. Everybody okay with this? You don't install the game on the same CD it was on, no? Everyone okay with this? Keyboard randomly stopped working. Oh. Try restarting and seeing. Laptop keyboard, external keyboard. Right. Everybody, we are moving down then. Guys, girls, everyone, we are going to move down to processors. Everyone okay with this? Guys, okay. Everyone, can you all see the bold words over? External. Try restarting and seeing. I don't know. Everyone, can you all see the bold words over here? Let's stop there for everyone. Look at me below. IPO cycle. What was IPO cycle? Input, process, output. So basically, your processor is converting your input into output or information, right? So guys, for input, whatever you give as your input, I told you can also call it data, isn't it? And whatever your computer gives you back, you can call it information. Excellent. So what is your processor converting? Exactly. Instructions into information, data into information, input into output. Are we okay with this? This is what your processor does. Converts data into instructions, input into output, or data into information. All three answers are completely fine. Are we okay with this? Okay, right. Then guys, tell me this. Your processor receives data from whom? From the RAM. Do you guys remember this? Everyone, what did I tell you? When you open Photoshop in your computer, Photoshop data files are where? Not in the RAM. Secondary storage, right? When you open up Photoshop, girls, when you open up Photoshop, Photoshop data files are in your secondary storage. Who takes them? The RAM takes them and gives them to whom to process? Gives it to the CPU, Central Processing Unit, for processing. Everybody okay with this? Can you all read this now? Everybody read this? It receives instructions from the RAM and processes it into information. Shall we have a look at this? Everyone look here. Control Shift Escape again. Okay, you all have to look because it's going to happen really fast. Okay, right now my CPU is not so busy. Okay, right now it's about 24% busy. Everyone over here, look here below. Right now my CPU is not that busy. If I were to open Photoshop right now, what should happen to my CPU? It should increase, right? It should get really busy, isn't it? Check it out. So I'm going to go into Photoshop. Let me zoom in also so you all can see what's happening on my screen. Photoshop. There you go. Can you see it got really busy here? Can you see how busy it is? Busy with whom? Photoshop, 4%, 5%. Okay. 7%. Can you guys see the numbers over here? Okay. 32%. Sorry, 3%. No, my bad. 4%. Okay. 3.6%. Okay. And now Photoshop opened up. Now Photoshop opened up. What happened? The numbers again came down because now the job is done. Finished processing. It has opened up now. Is it clear? So now it's not so busy. But can you guys see Zoom? Zoom is still running in the background. Zoom processor is still dealing with Zoom. So you can see it's about 12%. Everybody okay with this? Does it make sense? So guys, your processor is a very, very busy device. Okay, we are going to learn how busy is it right now. Okay, right. Now guys, everyone read here. Can you all read this confusing statement here? There's a confusing statement coming up. A processor is made up of multiple CPUs. Now that's really confusing. You just told me a processor. How does it have multiple CPUs inside it? Listen carefully. I'll ask you guys a question like this. Say, for example, in this classroom, I want to take all the furniture out of this classroom, and I have only one person with me, or rather, I have only one person to do the job. Do you agree? It's going to take a long time. That person is going to be really sweating. He's going to require a lot of energy. Agree with me? Boys, look here below. Everyone agree with me? If I wanted to empty the furniture in this classroom with one person, you can immediately tell me that person is going to be sweating a lot. He's going to require a lot of energy. It's going to take a lot of time, isn't it? What if we put two people in the room? Wouldn't the time half? Wouldn't the energy consumption half? It would, right? And wouldn't, I mean, the job would be done in a faster time, isn't it? What if we were to add 3 people? It would be even faster, right? 4 people, even faster, right? Agree with me. Now, guys, look at me. Everyone, look here. In your computer, guys, everyone, look here. This is your processor. It's a very, very tiny gadget. Inside this processor, you have multiple processors. Okay, multiple CPUs. But now that's a very confusing thing to say, right? one processor has multiple processors. It's a bit confusing, right? So guys, the multiple processors inside a processor, what do we call them? We call them cores. Everyone okay with this? So you have one processor with multiple cores inside. So guys, what are these cores doing? They are sharing the work. Everybody okay with this? It's like instead of one person taking out all the furniture, I have 4 people. So the workload is shared among 4 people. Everybody okay with this? So don't you think the job will get done faster? It's definitely going to get done faster because 4 people are working. Isn't it? Energy consumption will also go down because 4 people are working. Everybody okay with this? So now listen carefully, guys. You all understood what a core is, right? You all understood what a core is. Question? No.
Core is like that thing you check through control. You can check it.
We can check. 1 second. Core i3 is a model. Okay. I'm going to show you one more thing now. Have you heard the word quad-core, hecta-core, octa-core? For smartphones, normally you all would hear it, but it's also for laptops. So everyone look here. It's the, exactly. So everyone look here. Guys, look at this website. Now this website. So guys, normally when you all are purchasing phones, you would have heard this word. Quad-core, hecta-core, octa-core. 8 cores, correct. So iPhones all go with hecta-core processors. That means inside the processor, how many cores are there? Hecta is 6. Android devices are using octa-core. That means 8. Okay, Samsung devices. The Note series are all using octa. And then I'll show you all one more. So guys, look at this iPhone. Let's just go with the 16 Pro Max. Okay. Everyone look at this. What do you all see over here? Read this with me, guys. Hexa-core processor. Everyone okay with this? Hexa-core means there are 6 cores. So the workload is shared among 6 cores. Are we okay with this? If you go with the Samsung Note series, it would be octa-core. Okay. Samsung Note. Sorry? So everyone, if you look at the one second, please. Yeah. So guys, have a look at this. Can you guys say this? The Samsung, what does it say over here? Octa-core. You know about Pixel phones? What do they use? Pixel phones are using Nona-core.
9, 10.
Yeah, 9. Okay, so guys, check this out. Extremely fast. Not really. I mean,
But they still work.
it's not only the processor, the RAM, the storage, all have to work. Operating system. So guys, can you, no, sorry, this is the wrong one. Which one did I take? 9 Pro is not using it. They were using Nona-core. So guys, can you all see here? They are using a 9-core processor, which they call Nona-core. Okay, everybody. Guys, girls over here. So what did you all understand from here? So guys, let's go from the beginning. Initially, you had a processor with it was a single processor, no cores inside it. Then you had 2 cores. 2 cores was called dual core. Okay. Then we had quad core, where we had 4 cores. After quad core, we had 6 cores, which was hecta-core. Hecta or hexa? Hexa-core. Okay. Then we had octa-core, and now we have Nona-core. Okay. Not so funny. Okay, right. Guys, girls, can you all read this with me now? So, everybody, now look at me. Guys, girls, look here. Your processor is an extremely busy device. Since it is so busy, it produces a lot of heat. Okay, as it is processing instructions, all of y'all, it produces a lot of heat. So, right on top of your processor, do you know what we fix? The fan, the cooling fan. Boys, girls, everyone, look here below. Normally, right on top of your processor, the cooling fan is fixed because the processor produces a lot of heat. Everybody okay with this? Now, when the processor is producing a lot of heat, the fan is going to work really hard. Agreed? When the fan is going to work really hard, what's going to happen? Your energy consumption is going to go up, isn't it? So then your battery life is going to go down. Is this something users want? Users don't want this. So what do users want? Users want energy consumption to be low, right? We want the amount of heat produced to reduce. When the amount of heat produced reduces, does the fan have to work so hard? The fan doesn't have to work so hard. Then energy consumption is going to go down. So guys, how do we reduce the amount of heat produced? By increasing the number of cores. What did you say? Not you, man, the phone, the processor. How do we decrease the heat produced by the processor? Not by you guys, okay? What do you do, guys? You use multiple cores. When multiple cores are used, what happens? The workload is shared by multiple cores. Then the amount of heat produced goes down. When the amount of heat produced goes down, the fan doesn't have to work so hard. Everybody okay with this? So I showed you in GSM Arena. So when you're buying a laptop, in the specifications, they will tell you how many cores. Everybody okay with it? But let me just show you here also. Everyone in your laptop, if you right click over here, and if you come to, where is it? I forgot, manager, it's in properties. If you come to properties, it will show you there also. So everyone over here, it tells you that my laptop is using no, it doesn't mention the type, no? It just says the speed, not what type. I'll show it to you. So if I come to system information, if I come over here, it should show me. Everyone, you all saw this? How many cores? My one is using 14 cores. I forgot the name of this one. This is using, no. What do you say? I bought this recently. They mentioned it to me. Something different they are using right now for this. Anyhow, right, everyone, I'm going to move away from here. I forgot that name. Right, everyone, can you read this? Did you know fact, boys, girls? Read this. Did you know fact below? I just explained it to you all. Why do we have multiple cores? I explained it to you all. It's written in words over here. Can you guys read this? The main reason we have multiple cores, boys, the main reason we have multiple cores is to reduce the amount of heat being produced. That's one of the main reasons. Okay. All good there? One of the main reasons that we use multiple cores is to reduce the amount of heat produced. Okay. So the workload is shared. This saves energy and produces less heat. Okay. Read below. What's wrong? Okay. Zahir, come on, you read it. Okay. Come on, guys, in 2 minutes we'll be breaking. Can you all go through this? Okay. Right. So, guys, now I hope you all understood the purpose, boys, girls, the purpose behind our processors having multiple cores. Guys, can you all read these words? I'll explain it after the break to you all. Everybody, processor speed is measured in something called clock cycles per second. Confusing right now. For now, just remember it. After the break, I'll explain to you all what it means. Everyone? Boys, can you read that? Can you read this next sentence also? What do you mean by clock cycles per second? Boys, read it below. Exactly. The number of instructions carried out every second. Clock cycles per second basically tell you the number of instructions executed. Executed means what? Data becomes information. That's what you call an execution. Your instruction becomes information. That's an execution. Okay. So basically, the number of times per second the processor can carry out one or more instructions. So what are the units, guys? We have hertz, kilohertz, megahertz, and gigahertz. Okay. So we'll be learning how do we convert from hertz to kilohertz, kilohertz to megahertz. Everyone, please have your writing books. Okay. Yes, everybody, can we take this down now? Everyone, guys, girls, you all are noting down with me, please. Boys, everyone, can you all note down with me, please? So, yeah. Yeah. Guys, we are noting this down. Chapter 3 to now. For now, take this down below. You can take that. Measuring the speed of a processor. Guys, girls, can we all take this down? Measuring the speed of a processor. Okay. Is it readable from there? Okay. Right. Now, guys, I want you all to first write down the statement. Then I'll explain it to you all. Okay. 1 hertz. Everybody. 1 hertz. Okay. 1 hertz. Short form is capital H. Simple Z. 1 hertz means the processor can execute one instruction every second. Girls over there, everyone with me? What does 1 hertz mean? Every second, your processor can execute one instruction. Means the processor can execute one instruction every second. One instruction every second. Are we okay with this? Are you noting it down? Okay, this is the meaning of 1 hertz. Let's stop there for a second. What do we mean by execute? Exactly, converting data into information, converting an input into an output. Okay, can we note that meaning over here? Converting data into information. This is what you mean by execute. Okay. Converting data into information. Now, guys, 1 hertz is such a small unit in today's world, because today's world, your processor is so much more powerful. So much more powerful that one hertz is really, really small. Okay. So we need to learn of bigger units. Everybody okay with this? It's like this. If I told you guys to measure the weight of a lorry in grams, how big is the number going to be? It's going to be a really long number, right? Because the weight of a lorry is generally measured in tons, isn't it? We say 1 ton, isn't it? If you go to measure the weight of a lorry in grams, you're going to have a very long number. Similarly, computer processors are so powerful. If you use hertz, you're going to have a very long number. So we need to have a higher unit. Are we okay with this? So everyone, write with me. 1 hertz. 1 hertz. 1 HZ. You all know what HZ means, no? Hertz is equal to 1000 kilo. Sorry? No, 1 hertz is equal to 1000 kilohertz. Sorry. My bad. 1000 hertz. 1000 hertz is equal to 1 kilohertz. Everybody okay with this? Guys, girls? 1000 hertz is, so instead of saying 1000 hertz, you can say 1 kilohertz. So if I say 3000 hertz, how many kilohertz is it? You all understood that, no? You all simply divided by 1000. Okay? Then guys, 1000 kilohertz. 1000 kilohertz. Capital K, capital H, simple Z. is equal to 1 megahertz. Are we okay with this? 1000 megahertz. 1000 megahertz is equal to 1 gigahertz. And this is where we are stopping at. Everybody okay with this? Right. Now, guys, a simple question. Okay? Aren't you writing? Writing it down. Okay? Okay there. So, guys, if I were to ask you a question like this, convert 8,000 hertz to kilohertz. I think all of you all can answer this question without a problem. What did you guys do? So what you would do over here is you would take 8,000 hertz and you would divide it by 1000. Everybody okay with this? So then what do you get? 8 kilohertz. Now guys, I'll ask you all one more thing. 8 hertz and kilohertz. Okay? Hertz is a smaller unit than kilohertz. Agree? Hertz is a smaller unit than kilohertz. Agree with me, everyone? Hertz is a smaller unit than kilohertz. So shall I put a note over here? When converting from a small unit to a big unit, when converting from a small unit to a big unit, we must divide. Everybody okay with this? We must divide. Now everybody get this down below. Okay, when converting from a small unit to a big unit, you have to divide. Okay. So if I were to give you all the same question, convert 8,000 hertz to gigahertz. Convert 8,000 hertz to gigahertz. Exactly. Okay. So now how does it work, guys? You have to keep dividing now. So 8,000 hertz, girls, 8,000 hertz divided by 1,000 what? No. Go step by step. From hertz, we have, what do we have below? Kilohertz. From kilohertz again, we divide and go to, very good, megahertz. Then again, where do we go? Have we reached the destination? We have. You can also write your, gigahertz. You can also write your answer like this. Guys, you can also write your answer like this. 8,000 divided by, you can write your answer like this. 8,000 divided by 10 to the power of how many zeros? 3, 6, 9. And your unit here would be gigahertz. Are we okay with this? We are converting from a small unit to a big unit. Hence, we have to go this way. Scroll up for a minute, okay? No calculator. Hey, no calculator. You are not allowed to use in the exam also. Calculators are not allowed for you guys in your exam. I mean, ICT exam. Okay? Boys, shall we try the other way around now? Girls, boys, everyone. Now we learned how to convert from a small unit to a big unit now. Let's try the other way around. This is the easier way. From big unit to a small unit. Okay. So I'm going to give you all a question now. Convert boys 3 gigahertz to hertz. Everyone okay with this? Girls, boys, convert 3 gigahertz to hertz. Okay. 1 second, my tab has got stuck. Okay. Convert 3 gigahertz to hertz. Okay. Get down the question, please. Yeah. So, everyone, where are we? We are at gigahertz now. 3 gigahertz. Boys. So now we multiply. Everyone, can you look here? Guys, can you see? We are going from a big unit, from gigahertz, we are going all the way down to a small unit. Everyone with me? When you go from a big unit to a small unit, you need to multiply. So, gigahertz, what do you have below it? Megahertz, right? Before gigahertz, we have megahertz, no? So how much? 1000. Multiplied by 1000 megahertz. 1000 megahertz. Then from megahertz, where do we go? Just keep it there. Yeah, keep it there. I'll take it. Thank you. Kilohertz. Okay, then from here, where do we go? Very nice. Hertz. Then from here, we go to hertz. 1000 hertz. So guys, you can keep your answer like this, or you can simplify your answer. Okay, you can keep your answer like this, no problem, or you can simplify it. 3 multiplied by 10 to the power of how many zeros? 3, 6, 9. 9 hertz. So guys, if 3 is followed by 9 zeros, it is 3. If 3 is followed by 9 zeros, it's 3 billion. Okay, it's 3 billion. So if a processor has a speed of 3 gig every second, 3 billion instructions. Are we okay with this? If a processor has a speed of 3 gigahertz, it means every second 3 billion instructions it can execute. Are we okay with this? I'm going to show you guys something else now. How busy your processor is, I'm going to show you now. Okay? This will be our last thing for today. Okay? Guys, I want to show you guys how busy your processor is, how hardworking it is. Okay, give me a second. So we'll pick a random phone. Everyone, boys, girls, we'll pick a random phone. Okay. So I'm going to take, which phone shall I take? Shall we go with the iPhone itself? Okay, iPhone 16 Pro Max. Okay. Guys, girls, look here. This is our last part for today. Now, guys, look here. What did you all tell me about it? It's saying a hexacore. Everyone, look here below. In your textbook, can you all draw a line now and write measuring the speed of an iPhone 16 Pro Max? We'll just do this activity and then end it for today. In your writing book, yeah. Measuring the speed or the processor speed, measuring or calculating, measuring the processor speed, of an iPhone 16 Pro Max. Are we okay with this, boys, girls? Right. Okay. Now, guys, I want you all to have a look at this. Boys, look here below. What do you all see here? Guys online, you all put the heading now. Measuring this processor speed of an iPhone 16 Pro Max. Everyone with me? Girls, look here below. Now, guys, can you all understand the statement over here? Hexacore means 6. Hexacore means 6, isn't it? So, guys, can you all see? two cores are working at what speed? 4.05. I want to find the total speed every second. So can you all note that down? 2 multiplied by 4.05 gigahertz. Okay. How much will that be equal to? I'll tell you all. 1 second. And then there are 4 that are working at how much? 2.42. There are another 4 cores. There are another 4 cores working at a speed of 2.42 gigahertz. Now guys, 6 cores are there now. You all saw the 6 cores? 2 work at 4.05 and 4 work at 2.42. Now time to go back to my note. Do you all have something like this? So 2 multiplied by 4.05 will give you 8.1. Unit is gigahertz. Then the next one will be, why 9? It's 4, no? Okay. 9.68, correct. Okay, 9.68. Now can we add the 2 up? How much did you get? 17.78. Sure, no, I'm not checking it. Okay. 17.78 gigahertz. Okay. Now, guys, can we convert this into hertz so we can see the actual speed of the iPhone 16 Pro Max processor? Very nice. What did you say? 17 billion, isn't it? Now, you guys understood it, right? Okay, but anyway, we'll do the working below. We'll do the working. 17.78 gigahertz. We multiply by what? No, tell me step by step. Don't give me the direct answer. 1000 megahertz. 1000 megahertz. Then from this, where do we go? 1000 kilohertz. Then from this, where do we go? 17.78 multiplied by 10 to the power of 369. There are 9 zeros. 1 second, there is a delay between my tab and the screen. Sorry about the delay. Okay. 10 to the power of 9 hertz. Now tell me this in words. Every second, this processor can execute how many instructions? 17.78 billion instructions every second. This is the power of that processor. Are we okay with this, guys? Now, do you understand why your processor doesn't like talking to the hard disk? Because it's such a busy device. Sorry. It's such a busy device. It just doesn't have the patience to deal with the hard disk. Everybody okay with this? Which is why your processor prefers to talk only to RAM. Okay? Everybody okay with this? Sounds good? So yeah, I mean, iPhone processors are no joke. If you go and check Pixel or Samsung Note series, you might find an even higher number. Okay? So it's crazy. I don't know. Have check and see. Okay? Nowadays, devices are not using quad-core, nona-core. They're using a different type. My laptop is also using it. I forgot the name of it. Something else where the numbers are much higher and it uses AI to manage the processors for you and things like that. Okay.